Today's lesson is on measures of dispersion. A measure of a dispersion are measures that are used to describe the spread of the data items. How spread out are they? Similar to measures of central tendency, we had 4 different measures of central tendency. Here we're going to have 2 measures of dispersions that are going to measure the spread of the data a little differently. So for example, the mean temperature in Houston, Texas and Honolulu, Hawaii are both 75 degrees Fahrenheit. But Houston had an average high of 100 in the summer and an average low of 40 in the winter. Comparatively, Honolulu's temperature varies less throughout the year, usually only ranging from 60 degrees Fahrenheit to 90 degrees Fahrenheit. So only finding measures of central tendency doesn't actually show us the whole picture. Both Houston and Honolulu have a central tendency of 75 degrees, but the spread is different. So if we use both measures of central tendency and the measures of dispersion, we can understand the data set more fully. So the first measure of dispersion that we're going to be talking about is called the range. The range of the data set is the difference between the highest and the lowest data values in the set. For example, we have scores on a pop quiz are 8, 10, 9, 9, 6, 8, 9, and 7. So if I'm going to find the range, I just take the highest, which is 10, minus the lowest number, which is 6, and that gets me 4. So the range is 4. That just tells me the high minus the low is 4, so they're spread out over 4. Find the range for the following groups of data items below: 2, 4, 7, and 11. So I'm simply going to take 11 minus 2 and get 9. This tells me that the data values are much more spread out for my second set of values than my first. So between 2 and 11, that's much further apart than from 6 to 10 on our first example. The next measure of dispersion is called standard deviation, and it's a lot more difficult to find this measure of dispersion, but it's a lot more accurate, and we can do lots of interesting things with it if you pursue statistics. So the second measure of dispersion that is dependent on all the data items, not just the top and the bottom, is called standard deviation. It is found by determining how much each data item differs to the mean. We use S to denote the standard deviation of a sample. The standard deviation of a population uses a different letter, a Greek letter, but for this class we're just going to use S for the standard deviation of a sample. The process for computing standard deviation is as follows. Step 1, find the mean of the data set. Step 2, find the deviations of each data item away from the mean, meaning you're going to take each data item and subtract the mean from it. Then you're going to square that deviation. Then you're going to, step 4, add all of those squared deviations. So we're going to add them all up. And this big fat E is called summation. It's the Greek letter sigma, and it tells you to add up all of those, and that's what that means. Then in step 5, it says divide the sum that you found in step 4 by n minus 1. So we take the sum of the data item minus mean squared, divided by n minus 1. And then lastly, we're going to take the square root of the quotient that we found in step 5. This is going to be the standard deviation of the set. This is very detailed, and so we're not going to do very big sets for standard deviation. If you want to do the standard deviation of the large set, you'll probably want to use a computing software like Excel or a graphing calculator or some more sophisticated statistics software. But for this class, we're just going to show you how it works for very small data sets. So the standard deviation of a sample S can tell you how spread out the data items are. A low standard deviation indicates the values tend to be close to the mean, while a high standard deviation indicates that the values are spread out over a wider range away from the mean. So let's go ahead and try to do this on the next page here. So we have our pop quiz scores here. They're listed in my table here. There's 8 of them. So we have step 1, find the mean. So I'm going to add up all those values and divide it by 8. So we have 8 plus 10 plus 9 plus 9 plus 6 plus 8 plus 7 plus 9. Because there are 8 total data value items, I'm dividing it by 8. So I'm going to use my calculator. 8 plus 10 plus 9 plus 9 plus 6 plus 8 plus 7 plus 9. That gets me 66. And I'm going to divide that by 8, which is 8.25. So x bar is 8.25. Another thing to note is n is equal to 8. We wanted to note n because we'll be using that in the future. Next is steps 2 through 4. But I have it in a table here, so it's going to be easier for you to find those steps. So the first step is the deviation. So that takes the data item minus the mean. So my data item is 6, and I'm going to subtract 8.25 from that, and get negative 2.25. 7 minus 8.25 is negative 1.25. 8 minus 8.25 is negative 0.25. 8 minus 8.25, wait a minute, I just didn't I? Do I really have to write it all out again? Probably not, I could have just bring that down. Next, 9 minus 8.25 is 0.75 positive, and that appears 3 times. And then the last one, 10 minus 8.25 is 1.75. So that's step 2. Step 3 says to square those deviations. So I'm going to use my calculator and I'm going to square negative 2.25. I'm going to use parentheses and square it, and the square button, I have x squared here. If you don't have a square button, you can always take it and multiply it by itself. So that gets me 5.0625. Next I have negative 1.25 squared, 1.5625, negative 0.25 squared, 0.0625, and that appears twice because it's the same value. 0.75 squared is 0.5625, and that appears 3 times. And then our last one, 1.75 squared. Because it's positive, I don't need a parentheses. 3.0625. Step 5 says to add those squared deviations. So I need to add all of these columns. So I have 5.0625 plus 1.5625, and just be real careful that you're not missing anything. And I have 2 copies of 0.0625. So I'm just going to take 0.0625 times 2, because there's 2 copies of that. And then plus 0.5625, and I have 3 copies of that, so I'm going to multiply that by 3, plus 3.0625. And that adds up to be 11.5. And that was step 4. Step 5 says to divide the sum that we just found, 11.5, by n minus 1. Now n was 8, so 8 minus 1 is 7, so 11.5 divided by 7 is 1.6428. And then the last step to find the standard deviation, S, is I'm going to take the square root of 1.6428. So I'm going to do, in this case, the second button and then the x squared button so I can get that. Now I don't want to truncate anything, so I want to use the answer. If you have a calculator that you can store an answer in, that would be great. Otherwise, just type in as many places as you can so that you're not truncating anything too terribly. So this is going to be approximately 1.28. So my standard deviation is 1.28. Now that's pretty small with our data set, so a lot of my data value items are going to be pretty close together because that's what that is going to be saying. My standard deviation is fairly small.